Again, more on concepts lang tayo So, please review habang nagsasalita ako, kailangan na re-review kayo ng concepts ng chem So anyway, so let's start with the intermolecular forces, liquids and solids So, para ma-understand natin yung intermolecular forces, kailangan may idea muna tayo about how do they look like in general, So, saan nag-exhibit ang intermolecular forces natin? How can we perceive it, Paano natin sila na-observe, So, one way to observe the intermolecular forces of matter is by the phase of matter So depending on the phase of matter, there could be different intermolecular forces So ano ba yung mga phase of matter natin? So we have solid, liquids, and gases So for solids, ang particles ay clumped together So dikit-dikit sila. For liquids, there's quite some space in between them. Though dikit-dikit pa rin sila technically. However, for gases, the matter are spread out, Kalat-kalat sila sa buong space, So, yan. So, depending on the forces of attraction of each particles, depending sa kapit ng isang bilog diyan, ay iba-iba yung phase ng matter na pwede natin makita, So that means if the intermolecular force is strong, malakas yung kapit ng isang molecule to the other molecule, then we could observe liquids or solids forming, So kailan uli natin makikita yung liquids and solids if the particles are strong enough to bond with each other, So malakas yung kapit nila sa isa't isa. So we can expect solids and liquids forming. However, if the particles do not have that uh, that energy, wala silang attraction masyado sa isa't isa, then ang particles natin ay kalat-kalat, So again, paano uli yung logic ng intermolecular forces? Pag malakas ang intermolecular force, the particles will be close together, Naka-clump sila. Kasi malakas ang attraction nila, So kumbaga, kung sa tao yan, yung crush mo, tatabihan mo parate, So ganun din yung particles, If malakas ang attraction nila sa isa't isa, magsasama sila. So they will form either solids or liquids, Siyempre, strongest yung solid kasi dikit-dikit talaga yung particles dito. Dito, hindi gaano, Kaya nga 'di ba sabi sa mga friendship na super strong yung bond, 'di ba sabi solid. Kasi solid talaga yung depiction nila sa state of matter, So pero kapag hindi naman ganoon ka-close, the attraction is not that strong, then hindi yon solid, gas yon, So may ganun bang friendship? Meron, So yan. So kapag gas, the particles are not that attracted to each other. Mahina lang yung attraction nila. Kumbaga acquaintance lang, So tamang daan lang sa isa't isa. So you will see gases, Okay? So let's compare the phases of matter in terms of particles, energy, the spaces, and the attraction forces and the change in phase. So anyway, dito lang focus natin. So for solids, usually we have atom molecules for all naman and the energy profile of each phase of matter are different So solids, ito yung mga matter na low yung energy, not moving masyado So because they are not moving, ibig sabihin they will stay sa isang place lang So ibig sabihin nun mamumuo talaga yung solids natin because they are not moving around So they will clump together talaga. However, if the molecules started to moving, pag gumagalaw-galaw na yung molecules, then we can observe liquid forming or gases forming. So yung liquid, you still have particles na mababa yung energy. They are not moving that much, pero enough para hindi sila mamuo. So yung mga solid chunks, hindi na natin makikita for liquids. So the movement of particles is present here, So gumagalaw-galaw na sila. Okay. So parang naghahalo ka ng tubig, So the particles are flowing on top of each other. So that's for the liquids, But for the gases naman, Ito, yung particles talaga dito is highly energetic, masyadong magalaw. So as a result of them being highly energetic, kumakalat sila everywhere, no? So gases spread out evenly, 'di ba? So for example, may gas particles ng adobo, kakalat 'yun sa bahay nyo, no? Gas particles ng pabango, kakalat din 'yun sa bahay because the particles are energetic enough to spread out, no? Okay? So in terms of energy, gases ang pinakamataas ang energy, lowest sa energy ang solids, no? Tapos, with that idea, we can actually explain the phase changes, no? Kasi whenever we are changing the phase from solid to liquid to gas, what is just happening is that the particles are gaining energy, no? So for example, you hit a solid, no? Ano kaya pwede example? Yung yellow. So yung yellow, imagine that as ganito, no? If you add thermal energy to it, pag dinagyan mo yun ng energy, what will happen is that the particles of water, no? Yung particles sa ice, no? Yung water molecules doon, they will start moving, no? And as they start moving, they become separated to each other, no? So pag separated na sila to each other, pwede na sila mag-flow, no? So magkakaroon ka na ng liquid, no? So that means kapag yung yellow, dinagdagan mo ng energy. Teka lang. Okay, so that means yung kapag yung yellow, nilagyan mo ng energy, magfo-flow na sila to each other, no? May enough energy na sila for it to melt, no? Matutunaw na sila. So magiging liquid na sila. Then if you add more energy, kunwari pinakuluan mo na yung water, what will happen is that the particles will start going apart, no? Lalayo-layo na sila sa isa't isa, no? Hence, you will see bubbles forming. Makikita mo na yung gas particles ay lumalabas na out of the solution. So, yun. So, from the point of view of energy, we can explain the phase changes, no? So, the more energy you give to your system, that means the phases will change, no? From solid to liquid to gas. Pag nagdagdag ka ng energy, from solid to liquid to gas. However, kapag binawasan mo yan ng energy, for example, you place the gas sa refrigerator na super lamig, what will happen is that the energy will be lost, no? The energy of particles will be lost because malamig, no? So, habang lumalamig, since the particles are now slowing down, no? So bumabagal na yung particles kapag lumalamig, then what will happen, no? So pag mabagal na sila, magsasama-sama sila, no? They will come together to form liquids, then solids, no? So pwede sila mamuo, no? So ganito yung nangyayari when you place water in your freezer and outside the freezer, no? So when you place the ice outside the freezer, nilagay mo siya sa open air lang, no? So what happens is that the energy around you is being transferred to the ice, so the particles will start moving away from each other. So yung solid magme-melt to liquid. Then kapag dinagdagan mo pa yan ng energy, for example, pinakuluan mo, you will observe gases forming, no? However, try to do the opposite, no? For example, sa clouds, no? So in the atmosphere, maraming water vapor, no? So, in the higher atmosphere, malamig kasi doon, no? So, mga around 1 degree Celsius to negative something degrees Celsius na. So, since malamig in the upper atmosphere, that means the gas vapor, the water vapor ay babagal yung energy nila, no? So, as they slow down, they will tend to clump together to form liquid, no? So, yun. Pag naging liquid yan, pwede na umulan, no? And then kapag super lamig talaga, yung liquid na yan, pwede maging solid na tubig, no? Which is the snow, no? So, ganun lang yung phenomena ng phase change from the point of view of energy, no? Okay, so yun lang. Ano pa? Yun, spaces, no? So, again, for solids, they are tightly packed. Dikit-dikit sila, no? For liquids, may spaces onte, but not enough, not big enough, no? Then for gases, the particles are really separated from each other because of the high energy, no? So in terms of attractive forces, meaning the attraction of one atom to another atom or one molecule to another molecule. For solids, that's very strong, no? So masyadong malakas yung attraction nila. Kaya dikit-dikit sila. Hence, they are solid, no? For liquid, hindi ganun ka-strong, no? Pero okay lang, no? Para magsama-sama pa rin sila, no? But for gases, the forces are very weak, no? Mahina talaga yung attraction nila. Hindi talaga sila bagay sa isa't isa na magdikit, no? So they will separate talaga, no? Okay, so that's the point of view of the phases, no? Changes ng phase depending on the energy and the attractive forces, no? Okay, so ganun lang yung concept ng phase changes, no? So depending on the energy, your particles may move fast or may move slowly. Pag masyadong mabilis yung particles, pwede sila mag-transition from solid to liquid or gas. Pwede rin naman na kapag yung particles bumagal, they will condense from gas to liquid, then liquid to solid, no? So ganun lang yung idea ng phase changes. Ngayon, since we discussed the forces of attraction, ano-ano ba yung forces of attraction? So we have two forces of attraction, the intramolecular and the intermolecular, no? So let's define the two. When we say intra, similar analogy yon with intramuros, no? Intramuros. In Spanish, muros is wall, no? Intra, meaning yan, within, no? Kaya ang intramuros ay literally within the wall, no? The city within the wall, no? So that is the meaning of intramuros sa Espanyol, no? Okay, so intra meaning sa loob ng wall. Dito naman sa loob ng molecule. So intramolecular, sa loob ng molecule yung attraction. So what are the attractions inside the molecule, no? Paano natin sila makikita? Makikita natin yon in the form of chemical bonds, no? So pag sinabi nating intramolecular, ito ay chemical bonds lang, no? So the attraction of atoms in a molecule, no? So yun yung intramolecular. But when we say intermolecular, no? Parang internet, no? That is internetwork, no? Iba't ibang network, no? Ganun yung internet, no? So sa intermolecular, meaning nun, iba't ibang molecules ang may attraction, no? So kumbaga yung intramolecular, ito yung attracted yung mga particles mo sa katawan mo. Intermolecular, ito yung attracted ka sa ibang tao, no? So ganun yung idea lang. Intramolecular in the form of chemical bonds, and ang intermolecular ay intermolecular lang, no? Okay, so they are the forces that exist between molecules. I think visualization, this chemical bond is the intramolecular. That is the bond, that is the force that connects these two atoms. Intermolecular attraction naman, ito yung attraction between one molecule to the other molecule, no? So again, intramolecular, that's the bond. Intermolecular, yun yung attraction between one molecule to the other molecule, no? Okay, so let's have a review of intramolecular forces or the chemical bonds, no? So maraming uri ng bonds, no? So we can have ionic bond, no? So when I say ionic bond, the electron is fully transferred, creating ions, no? And those ions are attracted because of their opposing charges, no? So when we have a positive charge cation and a negative charge anion, we have ionic bonds, no? So yan. Ito lang ay dahil sa electrostatic forces. Ang meaning lang nun, yung positive attracted sa negative, no? So that's the ionic bond, no? For covalent bond, this exists for molecules without metals, no? Mga non-metal molecule usually gumagawa nito. So because of the small difference in electronegativity, the atom will not fully transfer its electron, no? And dahil na rin siguro sa octet rule, no? Kaya hindi sila nagiging ionic bond, no? Walang nagbibigay ng electron. Lahat sila gustong tumanggap ng electron. So they will have covalent bond, no? And may dalawang uri tayo ng covalent bond, no? Last time. Actually, tatlo yon. Kwentuhan natin. So for covalent bond, the first type is the nonpolar covalent bond, no? So nonpolar covalent bond, this happens when the electronegativity difference is less than 0.5 or 0.4, no? So pag less than yung difference doon ng electronegativity, then you have nonpolar covalent bond, no? So usually that happens if the atoms are the same or the electronegativity difference is very small, no? Ito yung mga sinusolve ninyo last time, no? So if the electronegativity difference is quite big, medyo malaki yung difference, then you will have a polar covalent bond, no? So what happens in a polar covalent bond is that the electrons are shared, no? However, because of the increased difference of the electronegativity, there will now be polar ends, no? So may polar ends na sila, no? So ayan, makikita natin na ang electronegativity ni chlorine is much greater than hydrogen, no? So that means chlorine will pull the electrons towards itself while yung hydrogen siya yung makukulangan ng electron, no? So that makes chlorine the partial negative end and the hydrogen the partial positive end, no? So makikita natin for polar covalent bond, we have partial charges, no? And whenever we have partial charges, we can call it dipole. Meaning ng dipole, may pole na dalawa. May positive pole, may positive end, and may negative pole, may negative end. No? So that is the dipole molecule. No? So whenever we have polar bonds, no, polar covalent bonds, we have dipole molecules. No? So ganon. And then the next one is metallic bonding. So sabi ko last time that nonmetals, yung mga nonmetals natin, they usually don't share electrons na. Oo, ganun din. Totoo naman yun. No? Kaya nga we are able to draw the Lewis structures, di ba? O, sa laboratory nyo yun, di ba? Yung mga Lewis structures, so on and so forth. No? Pero, siguro magtataka din kayo, no? Because, as you can see, itong pencil ko, may bakal dito siya sa ring, no? How come na magkakasama yung bakal dito sa ring? O itong ano ko, microphone stand, puro bakal to. Paano nagdidikit-dikit yung metal atoms, no? So the answer there is the metallic bond, no? So yung metallic bond, this is the bond between metal atoms, no? So akala nyo, yung covalent bond ay para lang sa non-metals, pwede rin siya sa metals, no? So if you have non-metals all or metals lahat, pwede yun mag-covalent, no? Pero if you have hybrid, may metal ka, may non-metal, ionic yon. Okay? So yun yung difference, no? So for metallic bonds, ang meron ka dito ay puro metal atoms, no? Okay? So what happens there is paano sila nagkakasama? Ganito yung illustration, no? So this is the nucleus of the metal atoms, no? And the valence electrons are then freely flowing around them, no? 'Di ba sa covalent bond ng nonmetals, yung electrons they are shared, no? Through chemical bonds, no? Sa metals, ganun din ginagawa nila, no? They share their valence electrons para masatisfy yung electrons needed ng iba't ibang atom sa paligid nila, no? So ang tawag dito ay sea of electron model, no? Instead of forming permanent bonds, what happens is that the electrons are just flowing from one nuclei to the other nuclei, no? And this makes the metals conductive. Yan yung dahilan kung bakit conductive sa electricity ang metal because of the flowing electrons on the surface, no? So ibig sabihin itong bakal na to, pag kinuryente ko to, the electrons will flow through this, no? So yun yung logic ng metallic bond, no? Okay. So if we are going to rank the intramolecular forces based on the strengths, no? So this is the ranking, no? So the metallic bond will be the strongest, followed by the ionic bond, then the polar covalent bond, and the non-polar covalent bond at the end, no? Okay, so ibig sabihin, mas malakas ang attraction forces ng metallic bonds. That's why yung metals natin, they are solid. Okay, kasi sabi natin, di ba, if mataas ang forces of attraction, that means Pwedeng solid, pwedeng liquid. But again, solid yung strongest ang force, no? So, yung metals natin, they are solid generally because their attraction forces is very high, no? So, yun yung highest intramolecular force, no? Followed by ionic bonds, no? So, yung mga ating ions, no, they usually appear as solids, no? For example, yung asin, yung ano pa ba yung mga salts? Baking soda, so on and so forth, no? So, they also appear solids, pero they are generally weaker than metallic bonds, no? Ito yung strongest talaga. Followed by the polar covalent bond, no? Ano example ng polar covalent bond molecule? Water, no? So, water, malakas yung attraction ng forces nila. However, we usually see water as liquid, not solid, no? Kasi, yung kanilang attraction forces is not so high as the previous two, no? Then lastly, yung nonpolar covalent bond, for example, is carbon dioxide, oxygen gas. Mapapansin nyo, puro gases yung mga nonpolar covalent bond, no? Because yung attraction nila ay hindi ganon kalakas, no? So, yun lang. So, tapos na tayo sa first part, no? The intramolecular forces. Again, when we say intramolecular forces, these are the forces of attraction within the molecule. No? And these are the types of chemical bonds that we can see for intramolecular forces. No? So now let's proceed with the next one, the intermolecular. No? So kanina, ang diniscuss natin is within the molecule. This time, we will discuss yung between molecules. From one molecule to the other molecule. Paano sila nagsasama-sama in peaceful harmony? So there are three general types of intermolecular forces. No? Number one is the dipole-dipole interaction. From the word itself, no, ibig sabihin nun, may isa kang dipole molecule at isa pang dipole molecule. So that means this force of attraction can be seen sa dalawang dipole molecules. No? One, for example, is hydrochloric acid, yun nasa muriatic acid natin. So, it is dipole. No? As you can see, paano natin nalaman na dipole yan? Because of the electronegativity difference. No? So, chlorine is much more electronegative than hydrogen. So, chlorine will bear the partial negative charge. Hydrogen will bear the partial positive side. No? Hindi lang naman itong molecule yung may charge. Yung iba din. No? So, ang gagawin nila is that they will align themselves. No? I-align nila yung mga molecules nila wherein the negative is facing the positive side of the other molecule. No? So, kumbaga, magfo-form sila ng chains, no? Magfo-form sila ng chains ng charges, no? Kung saan yung positive nakatutok sa negative, so on and so forth, no? So, that attraction is called the dipole-dipole forces, no? So, ganito yung itsura nun. For example, you have this dipole molecule, that dipole molecule. The positive and the negative ends are all alternating, no? So, ganyan yung mangyayari if you have dipole-dipole forces, no? Another type of this force is the ion dipole, no? So, ano meron sa ion dipole? So, you have a dipole, pero meron kang ions naman, no? So, yung ions, they mix with dipole molecules very well. For example, water and asin. So, if you place asin sa water, nag-mix siya. Bakit? Because the ions of the salt, no, yung asin, they can attract, they can be attracted by dipole molecules such as water, no. So, pwede sila maghalo talaga, no. So, yung positive cation mo that will be attracted to the negative end of your molecule, yung negative end ng yung negative ion mo, yung anion, that will be attracted to the positive end of the dipole molecule. No? So whenever you have ion and a dipole, ang tawag doon ay ion-dipole forces. No? So ganito yung nangyayari for water. No? Just one example. So yan. For example, this green ball is the sodium cation. So when you place sodium chloride sa tubig, this is what happens. No? Yung ating sodium chloride, they become ions. And what happens is that the cation will be then surrounded by water. Yung kulay red, yun ay oxygen. yung negative end ng water, no? So, itong mga negative end ng water, that will be attracted to the cation, the positive ion, no? So, ganun. Kunwari, ito naman yung anion yan. Yung hydrogen naman, yung tututok doon kay anion, no? So, the negative ion will be attracted to the positive, partial positive end of the dipole, no? So, yun yung reason bakit nagmi-mix ang ions sa water, no? Okay? So, yun lang. So, yun yung first part. Dipole-dipole, ion-dipole, no? So, kumbaga, that is just attraction between charges, no? Another type of dipole-dipole interaction is the hydrogen bonding. So, hydrogen bonding is the strongest intermolecular force, no? Yeah. May diin akong nilagay doon na intermolecular force, no? So, this is the strongest intermolecular force of attraction, no? Kailan natin nakikita yung hydrogen bonding? Whenever um, whenever hydrogen is bonded to atoms of oxygen, nitrogen, and fluorine. So that means we can see OH bond, NH bond, and FH bond, no? Exists only, ay, dito na lang. Saan siya nakikita? Bullet ko na lang. Okay. So the hydrogen bond only exists for these three types of bond, OH, NH, and FH. So dyan lang sila nakikita. Pag walang ganyang bond, walang hydrogen bonding yon. Okay? Okay. So yun yung nangyayari. No? So for hydrogen bonding, that is another type of dipole. Yes, dipole-dipole interaction yan. Pero special siya. Kasi this type of bond can only be seen sa tatlong bonds na to. No? So yan. So that is the strongest dipole, the strongest intermolecular force, and actually that is the reason why we exist on Earth, no? Kasi imagine if water, yung hindi siya nag-exhibit ng hydrogen bonding. Kunwari, typical dipole-dipole lang. Ang typical dipole-dipole kasi ay mababa ang boiling point compared to water, no? So yung water, ilang degrees Celsius para kumulo? 100, di ba? Alcohol, ilang degrees bago kumulo? Usually 85 degrees, no? Para kumulo yung alcohol. Actually, lagay mo nga lang sa kamay mo, 'di ba? Mag-evaporate na siya, no? So imagine kunwari, yung water is parang alcohol, no? Nag-evaporate agad sa earth. Is life possible kung ganon? Of course not, no? Because evolutionary people believes that yung existence of water, yung existence of hydrogen bond, no, that played a vital role in our existence today, no. So, ang world kasi before ay mainit, no. So, after mag-collide ng moon sa Earth, no, mainit yung Earth, then suddenly umulan na lang, no. Then, yun. So, kasi kapag yung water nag-evaporate agad, edi hindi nabuo yung primordial soup na tinatawag, no. So, without the primordial soup, walang living organism sa Earth, no? Kaya doon nila ina-attribute na whenever they find the planet with water, baka may life doon. Kasi based on evolutionary science, that is possible na kapag may tubig, may buhay na. So, kaya ganun yung mapapansin nyo sa mga balita kapag may na-discover na bagong planet, no? Inaalam agad nila kung may water, and yun. Yung kasi yung dahilan na. So, yung water, pag wala ng water sa Earth, patay tayo. As in, hindi tayo mag-e-exist. No? San pa? This also can be seen sa DNA natin, no? Especially itong NH, no? Our DNA bases, no? Yung mga nucleotides, no? They are attached to one another via hydrogen bonding. Itong mga NH bonds, no? So, di ba alam niyo yung DNA pairing? Yung adenine, guanine, cytosine, thymine, no? Or uracil for RNA, no? So, yung mga yon nagpe-pair sila because of the hydrogen bonding, no? So, yung one strand and yung other strand, they connect to each other due to the hydrogen bonding. So, malakas yon. Malakas yung force na yan. Kasi if the hydrogen bond is not strong, maarawan lang tayo, pwede masira DNA natin. So, lahat tayo nagka-cancer pag gano'n, no? But hindi gano'n yung case, no? Buti na lang malakas yung hydrogen bonding, kaya kahit ano gawin sa atin, kahit mainit sa Philippines, hindi tayo nasisiraan ng DNA, no? So, ganun lang. So, ayan. So, that's the hydrogen bonding. This is the strongest dipole-dipole interaction. The strongest intermolecular force of attraction. And last one is the dispersion forces or the London dispersion forces or the van der Waals forces. No? Van der Waals. No? F tapos V. German stuff. No? So, ano tong van der Waals forces? No? Ang concept ni van der Waals or the dispersion forces is ganito lang. Yung electrons, they can induce temporary dipoles. No? So, yung electrons natin, they can induce temporary dipoles. So, ano meaning nun? So, for example, you have a nonpolar molecule. Let's have Cl, no? May drawing pa ako dito. Ito. So, kunwari, this is our nonpolar molecule. Kunwari, bilog lang siya. So, kunwari, ito yung ating nonpolar molecule, Cl. Ito yung electrons niya sa paligid, no? It can actually, yung electrons niya can actually cause an induced dipole, temporary dipole. Parang biglaan lang na nagalaw yung electron. Kasi yung electron, remember, freely flowing yan, no? Umiikot-ikot siya dyan, no? Try mo hampasin yan, no? Pag hinampas mo yung electron cloud na yan, uurong yan sa isang side, no? Mas mababawasan doon. So, kumbaga, yung ating electron clouds, para siyang cloud, no? So, galawin mo lang, uurong siya sa kabilang side, no? So, ganun yung idea ng dispersion forces, no? Whenever you are disrupting the balance of electron, pag ginagalaw mo yung electron cloud, you have induced dipole. Bakit, no? So, for example, ayan, nung ginalaw ko yung electron cloud, napunta siya sa right side, no? Aray, hinampas ko dyan, no? Napunta siya sa right side. Napunta yung electron sa right side, no? So whenever the electrons are clumping together, ano nangyayari? Partial negative yung charge doon. On the other side, magkakaroon ng partial positive, no? Pero bakit siya temporary, no? Temporary kasi after the collision, kunwari, after niya bumangga dito, ano mangyari dito sa cloud, no? Magba-bounce back yan, no? Babalik yan sa original shape niya, no? Ngayon, ganyan uli siya. So, mawawala na yung dipole. Tapos, kunwari, hinampas na naman siya ng isa pang molecule. May ganito na naman itsura niya, no? Napupunta sa isang side yung charge, sa kabila, mawawala ng electrons. So, magiging positive yung charge. No? So, yun yung reason why dispersion forces are temporary. No? Yung electrons, pwede gumalaw-galaw, pero saglitan lang, temporary. No? So, kumbaga, may charge siya ngayon, mamaya wala. Tapos mamaya meron na naman. No? So, depende sa trip niya sa buhay. No? Okay? So, kailan na-i-induce yung charges na yun? Kailan nangyayari yun? Kapag meron kang cation sa paligid ng nonpolar molecule mo, or may dipole ka sa paligid ng nonpolar molecule mo. No? So, doon nagkakaroon tayo ng dispersion forces. No? Okay, so balik ulit tayo sa PDF. No? So again, dispersion forces, ano lang yung concept dito? The electron clouds, no? The disturbance in electron cloud can cause temporary dipoles, no? Temporary dipoles. So, yun. So temporary lang yung dipole, tapos mawawala. Tapos babalik ulit, tapos mawawala, no? So this usually can be seen sa lahat ng bonds, no? Lahat ng molecules merong London, no? May London dispersion forces, no? Okay, so lahat ng molecules meron nito kasi lahat naman ng substances may electron, 'di ba? So ayun lang yung concept na. However, if meron kang dipole, edi mas stronger yung dipole temporary. Okay, so that means if we are going to rank our intermolecular forces, ito yung ranking, no? So dipole is strong, hydrogen bonding is the strongest, and London dispersion is the weakest, no? Okay, so weakest itong London dispersion forces. Bakit? Kasi nga, temporary lang yung charge, no? Nawawala din. Okay? So, unlike the dipole and the hydrogen bond, permanent yung poles nila, no? So, may positive and negative end talaga sila. That's why strong sila. And London, saglitan lang. So, nawawala din, mas babalik, so on and so forth. Okay, so that's the idea for the intermolecular forces. No? Okay, so ganun lang. Yun lang. Ano pa ba kailangan ko sabihin? So again, let's summarize. No? So ano yung mga forces of attraction natin? We can have intramolecular force and the intermolecular force. No? So when say intramolecular force, no? Kapag intra, this is the bonds. No? So may apat na bonds tayo this time. We have the metallic, which exists between metal atoms. No? We have the ionic, which exists between metal and non-metal atoms. The polar covalent, which exists between covalent molecules with big electronegativity difference. No? And the nonpolar covalent molecule, ito naman ay kapag mababa lang yung electronegativity difference. No? So ranking them, metallic will be the strongest, followed by ionic, then polar, and lastly, nonpolar covalent bond. No? Okay? So for intermolecular forces naman, ito yung mga forces of attraction, dipole-dipole. This exists for dipole molecules. No? One dipole molecule, other dipole molecule. So may attraction doon between the positive and the negative end of each molecules. So strong yung attraction na yon. However, hydrogen bonding yung strongest version of dipole-dipole. No? So experimentally, siya yung strongest na. Okay, so that only exists dito sa HF, HN, and or bakit HF uli yan? OH bond na. HO bond na. So, dyan lang yan nag-e-exist. No? Pero kapag wala niyan, edi dipole or kung wala talagang dipole, London forces. No? So, this is the strongest followed by the dipole and lastly, the dispersion forces. This can be seen sa lahat ng molecules. No? So, yan. So, and also temporary rin to. So, nawawala din. So, parang ano lang, saglitang ano lang, charge. No? Saglitang attraction lang. Kumbaga sa tao, infatuation yan. No? So, temporary lang, hindi siya permanent. No? Okay? So, yun lang naman. Ano yung pwede kong bigay sa inyong tip? No? Yun lang, just look at the formula, look at the structure. Kasi ganun ko in-style yung quiz dito. No? So, yung quiz dito, nakalagay na yung structure, makikita nyo na. No? Just check kung may dipole siya or may hydrogen bond. No? Kailan mo malalaman kapag may hydrogen bond? When you can see OH. Pag may OH doon na magkadikit, hydrogen bond yon. O kaya kapag may NH at FH, hydrogen bond yon. Tapos kailangan alam nyo rin yung kailan siya magiging dipole. Kailan uli magiging dipole? When the electronegativity difference is quite big. No? So between 0.4 to 1.8 na. So pag within the range yung electronegativity difference, then you have a dipole molecule. Anything lower than that, for example, carbon-hydrogen bond, yun ay mga dispersion forces. No? Okay. So anyway, yun lang. Okay, and also pala, no, depending on the strength of the intermolecular force, makakita ka ng iba't ibang phase of matter. No? So the stronger the intermolecular force, the solid it becomes. No? The weaker the intermolecular force, the gaseous it becomes. No? So solid, ito yung malalakas. Yung gases, ito yung mga weak. No? Mga may hinang attraction forces. So yun lang. So punta na tayo sa next part of our discussion, which is on liquids naman. So, okay. So we can explain the liquid phenomena, dalawa lang naman yan, depending on the intermolecular forces. No? So one is the surface tension. The surface tension is the elastic force of the liquid surface. No? Ibig sabihin magko-curve yung liquid mo, no? Such as seen here sa water strider. Kung nanonood kayo ng Jackie Chan, alam niyo yung water strider, no? Sa anong movie 'yun? The Tuxedo. So yan yung mga water strider, they can walk on water. Parang Jesus Christ lang, no? Kasi yung feet nila, they are designed to walk on water, no? So, designed sila mag-walk sa water. Okay, so yun lang. So, that's a visualization of the surface tension. And syempre, wala namang water strider ato sa Philippines. One way to see the surface tension happening is tingin kayo sa glass tubes, no? May mga test tubes natin. So, even sa baso, no? Makikita nyo sa dulo ng baso, the liquid will curve upwards, minsan downwards, no? Okay, so that curve of water ay dahil sa surface tension. So, may yung curvature ng water dahil yan sa surface tension. Question dyan is, bakit siya magka-curve, no? So, two reasons, no? It can curve because of the cohesive and the adhesive forces, no? So, differentiate natin yung dalawang yan. So when we say adhesive forces, that means your liquid is attracted to the other substance, no, or to the other object, no. So ibig sabihin nun, if attracted yung liquid sa other objects such as glass, didikit siya sa glass, no. Kaya siya adhesive, kakabit sa glass. And whenever you have adhesive forces, you can see that the meniscus is yan. Ano tawag dyan? Concave, no? So, instead na flat lang yan, what happens is that the water level is curving upwards, no? So, nagka-curve siya pag ganun. Dumidikit yung water sa gilid, no? So, the curvature of water that causes this concave meniscus ay dahil sa adhesive forces. When water is attracted to the molecules of the glasses, no? Yan, adhesive, didikit siya doon. Bakit? Ito kasi yung reason, no? Yung ating glass ay polar. Ang water ay polar din, no? So, polar at polar, match yun, no? Magmamatch yan sa Tinder. So, ganun din sila, no? Uy, match tayo, magdikit tayo. So, magka-curve sila, no? Magka-curve yung water upwards. So, you will see a concave meniscus, no? So, ito yung adhesive forces. Ano yung makikita kapag adhesive? Concave, no? Concave yung meniscus niya. Didikit yung water sa gilid, no? So, mag-spread siya ng paganyan. However, if hindi sila matchy-matchy, pag hindi sila magka-level, hindi sila magdidikit, no? And for that reason, magkakaroon tayo ng outward curve, no? Itong outward curve na to, instead of flat, no? Itong outward curve na yan, ang tawag dyan ay convex meniscus, no? This happens because of the cohesive forces, no? Ang cohesive forces, ang meaning lang nun is ayaw ng liquid na katabi yung kabilang side niya because they have different forces of attraction. No? So for example, this one is mercury, this is metal. Ang katabi niya ay polar, yung glass, no? So polar to, metal yung isa, magsasama sila? Hindi. Ayaw nila. Okay? So may differing opinion sila kaya hindi sila match, no? So unlike the adhesive forces, they have the similar force of attraction kaya sila magsasama, no? So yun lang yung kwento diyan, no? So that's one liquid phenomena, no? The curvature of liquid. We call that the surface tension. And may dalawang uri ng surface tension. We can have the adhesive and the cohesive forces, no? So adhesive, didikit yung water sa katabing substance because of the similar forces of attraction. Kung polar yung isa, magdidikit sila. Cohesive yan. Pero if they are not polar, then cohesive, no? It will form a convex meniscus. You can actually use this, no, to check whether if you have a mercury thermometer at home, no? Kasi way back 2000s, no, mga bata pa ako noon. Ilang taon ako noon? Mga 3 years old data ako, 2000, no? 1998 ako eh. Mga 2 years old lang pala ako noon. Naalala ko kasi we have a mercury thermometer, no? Ako bata pa, medyo malinaw pa memory ko. Even yung 9/11 naalala ko rin, no? So yung mga ganung bagay, naalala ko yung mga ganun. So yung mercury, pag tinitignan ko yung dati nung bata ako, yung curvature niya is pag ganito talaga, no? Pa-convex, no? Tapos nung nag-high school, nasagot yung question ko, bakit kaya naka-curve yan upwards? Ang reason lang pala is because of the surface tension and the cohesive forces, no? So, yan. Naka-curve upwards ang mercury. Kapag yan ay alcohol thermometer, which is the currently used thermometer ngayon, hindi mo makikita yung upward bulge na yun. Hindi siya convex. Naka-concave yan. Because ang alcohol is polar, yung OH bond doon, dipole yan. OH, hydrogen bond yan. And the glass is polar as well. So, magka-concave yun. So, saan doon papasok yung pag-check ng thermometers, no? So, tignan nyo yung thermometer nyo kung yung dulo ay pa-concave or pa-convex. Pag pa-convex yun, wag nyo na gamitin. Kasi mercury yan, pag ganun. Pag concave yan, pag naka yan, nakapa-letter U, yung concave meniscus, that's alcohol and that's safe, no? So, yun. Ang nangyari kasi sa thermometer na yun, nabasag yun eh. So, hindi ko alam kung paano nila nilinis, pero, ayun, wala naman akong naging sakit, no? Hindi ko sure. Basta yun yung idea, no? So, makikita niyo sa thermometer, pag yan ay naka-convex, kabahan na kayo. Pag yan ay naka-concave, okay lang yan, no? Kaya pwede naman kayo digital thermometer or infrared thermometer, no? So, yun lang. And then the next one is viscosity, no? So, when you say viscosity, this is the resistance of fluid to flow, aka in Tagalog, yung lapot, no? Gaano kalapot yung liquid, no? So, the lapot of a liquid or the viscosity of the liquid is dependent also on the intermolecular forces, no? The stronger the intermolecular force, the more malapot your liquid is, no? Pero the weaker intermolecular force, ibig sabihin nun, hindi siya malapot, no? So, one good example is the arnibal, no? Yung asukal and ang tubig, no? So, kunwari umaga ngayon, usapang arnibal tayo. Ito, hindi ko alam kung anong sugar molecule to. Hindi ko alam kung anong sugar molecule yan. Pero this is beta glucose ata. Anyway, so ito, this is sugar molecule. Ganyan itsura ng mga sugar molecules natin. No? Nakaparing sila. Lakihan ko yung drawing. Wait lang. Yan. Okay, question. Sino mas malapot? Water or sugar? Caramelized sugar? Arnibal? Of course, the obvious answer is arnibal. Bakit? Yun yung tanong, bakit? We can say that malapot siya because of the strong intermolecular forces. No? Yun, acceptable na yung answer na yun. Pero how? Paano naging strong yung intermolecular forces dito kaysa sa water? Okay, so let's check the intermolecular forces that these two molecules exhibit. No? So ano kaya pwede natin makita dito na forces of attraction? Tignan nyo, yung water may OH dyan. OH. Oh, hydrogen bond yon, di ba? So you have hydrogen bond here on the left. You have hydrogen bond also here on the right. No? So kumbaga, you have two H bonds, no? Sa isang molecule. Hydrogen bond here, hydrogen bond there, no? So two hydrogen bonds yan. Okay? So tignan mo yung tignan mo yung asukal. Ilang OH ang makikita mo? This is 1. This is 2, 3, 4, and 5. 5 OH bonds ang meron ka, no? So may 5 H bonds ka, no? Ayusin ko muna. So you have 5 H bonds, tapos may dipole ka pa dito, no? This is carbon, oxygen, dipole yun, di ba? So may isa ka pang dipole other than the H bond. So san mas malakas yung forces of attraction? San mas marami? So syempre, obvious answer is the sugar, no? So looking at the sugar, marami siyang OH bonds, may dipole pa siya, may London forces pa yan kasi everything exhibits London forces. No? Lahat ng bagay may London force. So ano meron sa kanya? H bond, may dipole at may London force. Yung water, H bond lang at London force. No? Okay, so ibig sabihin nun, since the intermolecular forces of glucose, no, or the sugar is high, mataas ang attraction nila sa isa't isa, then meron tayong viscous material, no? Malapot siya. Bakit nga ba nagiging malapot? Kasi imagine liquids as layers of molecules, no? So kapag malakas yung kapit ng molecule, hindi sila magsa-slide past each other, no? Hindi sila agad-agad magsa-slide sa ibabaw ng kabilang molecule, no? So hindi mabilis yung flow, mabagal. Bakit mabagal? Kasi masyado silang attracted sa isa't isa. Kumbaga mayroong glue, no? Ito may 5 glue, ay may 6 na glue, ito 2 lang, no? So ibig sabihin nun, mas mabagal yung flow ng sugar compared to water, no? That's why arnibal is more viscous than the water, no? So the next time na magtataho kayo, yan, sabihin nyo, Kuya, H-bond yan, no? So ganun lang. Malay mo, bigyan ka ng free taho, no? Wala na sa amin nagtitinda ng taho eh. Pero yan lang yung reason, no? Kung bakit ganun. Okay? So yan yung reason bakit malapot yung mga bagay, no? May mga H bonds, no? Meron ding dipole, no? The more IMFA na meron, the more intermolecular forces, the viscous the material is, no? Sir, paano kung walang H bond, walang dipole? Let's take for example this alkanes, no? Mapapansin mo, lahat ng bonds dyan ay nonpolar. Carbon, hydrogen, and carbon-carbon bonds yan. So, nonpolar to lahat, no? Pero looking at the viscosity, mapapansin nyo, the more atoms you have, the viscosity gets higher, no? So, this is 3.26 times 10 raised to negative 4. Pagdating sa decane, that's 1.42 times 10 raised to negative 5. So, yung viscosity niya ay tumaas, no? So, that means, no, ang prevailing force dito ay London force, no? So, the more atoms you have, the more electrons you have, no? And if you have more electrons, then the chances of producing instantaneous dipoles or temporary dipoles is more likely, no? Yun lang naman yung concept ng dipole eh. More electrons, more chances of forming dipoles. No? So, ibig sabihin nun, mas malakas yung forces of attraction kapag mas maraming electrons. Okay, so that's why mas malapot ang decane compared to hexane. Ano yung example ng alkane na sobrang lapot? Fuel, no? Yung mga car oil, no? So, mga alkanes lang yun. Malalapot sila, no? Yun, kasi super dami ng carbon na nandun, no? As in, around 18 to 20 plus, no? So, yun lang yung example nun. So, the more atoms you have, the more dispersion forces you will also have, no? So, yun lang yung sa liquids, no? Again, what are the liquid phenomena? Surface tension. That's the curvature of liquid. That is due to the adhesive and cohesive forces. No? So pag adhesive, gusto niya kumabit sa liquid, gusto kumabit ng liquid sa katabi niya, hence it will form a concave meniscus. Pero kapag cohesive force, ayaw niya tabihan yung katabi niya kasi hindi niya kamatch ng intermolecular force. Hindi sila parehas. So it will form a convex meniscus. No? By the way, nakalimutan ko to daanan. Mapapansin nyo na yung liquid dito sa adhesive force ay umaakyat sa gilid, no? Kaya siya nagpo-form ng concave meniscus. The rising of liquid in a tube is called the capillary action, no? So, itong liquid dito, umaakyat siya sa gilid, no? It crawls up sa sides ng glass, and that force is called that phenomena is called the capillary action, no? So, saan nyo nakikita yan? Sa medtech, no? Usually, sa blood sample, may capillary tube kayo. Yung capillary tube is super tiny na tube na pag pinatong nyo yung capillary tube sa blood, aakyat yung dugo doon. Aakyat yung liquid sa capillary tube. Pag nagganong kayo sa, kunwari, face-to-face classes na tayo next sem. Sana naman. Nakakapagod yung online eh. So, pag kunwari, dinikit mo yung capillary tube sa blood, umaakyat yung tubig doon. Sabihin mo, capillary tube, capillary action yan, no? The rising of liquid sa tube, no? That's because of the adhesive forces ng iyong materials, no? Glass is polar, blood is polar, so aakyat yung liquid sa tube, no? Okay? Then we have viscosity. So the more intermolecular forces, the more viscous the liquid is, no? Mas malapot siya, no? Okay. So for solids naman, I will use this PowerPoint. Mas maraming picture dito, no? Okay, so for solids, dalawang uri ng solids meron tayo, no? So we have crystalline solids and amorphous solids, no? So when you say crystalline solids, the order of the particles are well defined, no? Maganda yung structure niya. Pag amorphous solids naman, ang particles ay not arranged, no? Does not possess a well-defined arrangement. So ibig sabihin, the structure is gulo-gulo, no? Pag crystalline, maayos yung structure. So depending on the structure of solids, you can either have a strong solid or a brittle solid, no? So ano yung example ng mga strong solid? Let's say yung mga glasses sa ating devices, no? Sa ating mga cellphones, sa ating watches, no? Yung mga Corning Gorilla Glass, mga sapphire, no? So yun yung mga crystalline solids, matitibay sila, no? Kasi ordered yung structure, no? Pero kapag amorphous solid yan, hindi yan matigas, no? Onting hawak mo lang dyan, pwede masira siya. Ano example nun? Kunwari, yung may clump ka ng baking soda, pisilin mo yon, di ba, masisira agad, no? So, amorphous solid yon. Ano pa example? Sa mga babae, yung makeup nyo. The makeup is actually made of talc, no? That is the weakest form of solid, no? Yung talc, ano? So, pindutin nyo yon sa gilid, nasisira agad yung solid, di ba? So, yun. Kasi mahina yung arrangement ng particles, no? Amorphous kasi siya, no? So, ganun, no? Ano pa example ng amorphous? Yung chalk, no? So, yung chalk, na whiteboard chalk, no? Pag pinisil mo yon, masisira agad yung chalk, no? Because the arrangement of particles is not well defined. No? So again, may dalawa tayong uri ng solids, no? We have crystalline and amorphous solids, no? So for crystalline, mayroong ordered structure, no? So ano kaya yung mga itsura ng ordered structure nila? So pwedeng ganito yung shapes nila, no? So naka-arrange sila ng ganyan, no? Mukha siyang maganda, pero may maraming math involved dyan. So hindi na natin papasukin. Okay? Pero if your high school teacher, no, yung senior high school teacher nyo ay pinag-solve kayo ng unit cells, no, mga number of atoms, then alam nyo na kung gaano ka terrific yung subject na to, no? Kung gaano siya ka math intensive, no? Kasi yung senior high ko pinapaganon ko eh, no? So solve kami ng mga algebra niyan, no? Kasi may mga ganyan-ganyan, no? So yan. So ano lang yung idea dito, that for solids na crystalline, ordered ang ating structure, no? May patterns silang sinusunod, no? And because of the good pattern of those atoms or molecules ng crystalline solid, then ano sila? Matibay sila. Kasi maximized yung dikit-dikit ng molecules, no? Maximize ang forces of attraction. Okay? So that's for crystalline solids, no? Paano naman yung amorphous solids? Yung amorphous solids, kalat-kalat sila, no? So, for example, this one. Yung glass, pwedeng amorphous yan, pwedeng crystalline, no? So, an example ng glass na matibay, yung mga quartz, no? Yung mga nasa relo na, basta yung mga nasa relo, no? Mga Rolex, yung mga ganun. So, mga quartz yun nandun. So, matibay yon, scratch resistant din, no? Kasi matibay yung solid, no? However, if low quality yung glass, mabilis yun masira, no? For example, yung mga nasa bintana natin, no? Mabilis masira yon because the crystalline structure is not good, no? Ito maayos, dito hindi, no? And because of this, kalat-kalat siya. So, yan, mabilis yan masira. Okay? And going back tayo sa crystalline solids, no? So may iba't ibang uri tayo ng crystalline solids, no? So we have ionic crystals. Ano meron sa ionic crystals? We have ions. No? One example here is the sodium chloride crystal, yung salt. No? Tignan mo yung isang butil ng salt particle, naka-square yon. Kasi ganito yung itsura ng unit cell niyan. No? So, ganyan yung itsura ng particles doon. Naka-square din. No? So, yan. So, that's for ionic crystal. Ano meron sa ionic crystal? We have ions. No? Another type of crystal is the covalent crystals. Instead of ions, we have atoms here, such as diamond, no? Graphite, no? So, yan. Diamond, puro carbon atoms lang yan. No? Graphite, ganun din, no? So, ginagamit to sa mga carbon nanotubes, no? Carbon fibers, no? So, matitibay yun, di ba? Yes, no? Kasi maayos yung kanilang arrangement ng arrangement ng particles, no? And again, so ionic. So for ionic, we have ions. For covalent, we have atoms lang. And the next one is the molecular crystal. An example nito, yung yellow. No? So yung ice, that is a molecular crystal. No? When water molecule arranges itself accordingly, no? Nakaayos siya ng arrangement, pwede siya mag-form ng solid ice. No? So yung ice. Pero ano mapapansin nyo doon, yung crystal ng ice is mabilis masira, no? So mahina yung kanyang strength, no? Compared to the covalent and the ionic, no? And last one is the metallic crystal. Ito yung mga metals natin such as my microphone stand, no? So matibay din to. Ito yung pinakamatibay sa lahat, no? So yan, you have your nucleus of the different atoms. Around it are the electrons, no? So yan yung mga electrons natin, no? So in summary, these are the types of crystals, no? So we have ionic, we have ions there. Covalent, we have atoms. Molecular, we have molecules, no? And metallic, may metals doon, no? Okay, so yan lang. Ano pa ba? And lastly, no? So tapos na tayo sa intermolecular forces of attraction. Nasa liquids na tayo kanina, nasa solids. And for the last part of the discussion, i-discuss ko na lang yung phase changes, no? Phase changes, asan na yun? Okay, so ito, phase changes, no? So again, ang concept ng phase changes is that depending on the energy of your matter and the strength of the forces of attraction, depende sa lakas ng attraction nila at sa energy na meron sila, they can transition from one phase to the other, no? So if mahina yung forces of attraction, hindi sila solid, pwede silang liquid or gas, no? Pag strong yung forces of attraction, pwede silang liquid or pwede silang solid, no? So, ganun yung itsura ng ating matter depending on the intermolecular force of attraction. No? Then, as you increase the temperature as well, no, ano nangyayari? No? The particles become energetic and they will move. No? As they move, they transition from one phase to the other. No? So, if ang transition ay from solid to gas, that's sublimation. Solid to liquid, that's melting. Liquid to solid, freezing. Liquid to gas, vaporization. Gas to liquid, condensation. And gas to solid ay deposition. So, yun. So depende sa energy and sa available force of attraction, pwedeng may iba-ibang phases of matter tayong makita, no, sa ating substances. No? And hindi na tayo magsusolve ng sandamukal na equations. No? Wala na yung mga ganyan-ganyan, no? Ayun. So anyway, so we can describe the ano tawag na? We can describe the transition of one state to the other, no, ng ating matter with phase diagrams. No? So ito yung summary ng conditions ng ating matter depending on different pressure, different temperature, at kung ano yung appearance nila. Whether solid sila, liquid sila, or gas sila. No? So, paano to basahin? No? Kunwari, at 1 atmosphere, dito ka matitingin, no, sa line na to. So, if you have temperatures below 0 degrees, then you will expect na yung water ay solid in the form of ice. If you increase the temperature, what will happen is that you will cross this line, itong blue line na to. This line is the melting curve, no? So, dyan magme-melt yung ating water. Then, pag lumagpas ka dyan, you have liquid, taas mo pa yung temperature. Then, pagdating dito, you will encounter another curve, which is the vaporization curve, no? Dito yung evaporation mangyayari. Then, anything beyond that, gas na yung iyong water, no? So, may mga distinct regions dito sa phase diagram, such as this one, the intersection of all the curves, no? The melting curve, the vaporization curve, and the sublimation curve, no? No. So, yung intersection nila, this is called the critical point. I mean, the triple point, no? Triple point yan. So, ano meron sa triple point, no? So, at triple point, you have three phases of matter coexisting all at once, no? So, yung matter natin, 3 in 1, no? Parang trinity lang, no? So, solid siya, liquid siya, at the same time, gas din siya, no? So, depending on your substance, iba-iba yung kanilang triple point, no? Such as, for example, carbon dioxide, ang triple point niya ay nandito, no? So, yan yung triple point niya. Okay, so yun lang. Tapos, somewhere here sa dulo, putol kasi to, no? You can have your critical point, no? So, punta ako dito sa kabilang slide, no? Okay, so ito, tingin tayo dito. So, ito yung triple point, di ba? Somewhere there, sa end ng liquid and gas curve, no? May makita kayong point doon. Tas anything beyond that is wala ng curve, no? Wala ng separation. This point is called the critical point wherein your matter can be last seen as liquid and gas. Ito na yung last point kung saan may distinction between liquid and gas, no? Anything beyond that, you will have a supercritical fluid. So, ano meaning ng supercritical fluid, no? Meaning nun is that it is liquid and gas at the same time. Sa triple point, solid, liquid, and gas sila at the same time. Pero pagdating sa supercritical fluid, liquid and gas sila at the same time. No? So, hindi mo makita yung difference between liquids and gases. Ayun. So, yan. So, at supercritical point, anything beyond that, you have a supercritical fluid wherein yung liquid and gas, they are no longer seen as separate phases. No? Hindi mo na sila makikita as magkahiwalay na phases. No? So, magsasama na sila. No? Okay, so ang last activity ko na lang sa inyo is, bukod sa mag-aral kayo ng maigi, is manunood lang tayo ng triple points and critical point. No? So, allow me to search for the video muna. Hanapin ko lang. Dito pala sinave ko na. No? History. Ayan, so alam nyo na yung mga pinapanood ko sa YouTube, no? Na-share ko na ba? Ayan. Okay, so punta natin yung triple point and the critical point, no? So panoorin natin tong dalawa, no? So punta muna natin yung triple point, no? Teka lang, di ko lang kung naka-share yung audio. Wait lang. Para mapanood nyo, no? Kasi after this, magpapahinga naman kayo eh. No? Panoorin na natin ngayon. Okay, so we have two videos explaining the triple point and the critical point, kung ano itsura ng matter at such points na. So, umpisa natin sa triple point na. Nangyari. Wait lang ha. Okay ka lang, girl.
When we switch off the
Ayan, panood muna tayo.
Imagine the same substance existing as a solid, a liquid, and a gas, all at the same time. Sounds impossible, doesn't it? It's what's known as the triple point, and we are going to demonstrate it now. Any pure substance can exist in three phases. It can be a solid, a liquid, or a gas. We can show these phases using a pressure-temperature diagram called a PT diagram. This graph shows the location of the different phases of a pure substance in relation to pressure and temperature, with pressure P on the vertical axis and the temperature T on the horizontal axis. The three phases are separated from each other by so-called separation lines. There's a melting line between the solid and the liquid phase, a sublimation line between the solid and the gaseous phase, and the vaporization line between the liquid and the gaseous phase. The triple point is the location where all of these lines meet. It is specified by a certain pressure and temperature that is characteristic for each substance. If a pure substance is at these specified temperature and pressure values, all three phases will be present at the same time. One says that the three phases coexist. Pure water has a triple point temperature of 0.01 degrees Celsius and a triple point pressure of 611.5 Pascal. This is the same as about 0.6% of the usual atmospheric pressure. At this point, water will exist both as ice, as liquid, and as vapor. Let's see what this looks like in practice. For this experiment, we need a vacuum chamber which is connected to a vacuum pump. A combined pressure and temperature sensor is connected to the hose between chamber and pump. It is also connected to a PC via USB, and values of absolute pressure and temperature in degrees Celsius can be shown on the screen. Inside the chamber, we place a petri dish with liquid water. After the chamber has been sealed, the pump is switched on. Both pressure and temperature start decreasing immediately. During evacuation, the liquid water starts to boil as the pressure drops to the saturation pressure at the given temperature. The glass beads reduce the splashing of water during boiling while the pressure decreases. They will also provide nucleation sites for the other two phases. While the pressure drops quite quickly, it takes longer for the temperature to approach values around 0.01 degrees Celsius. Unfortunately, our pressure sensor cannot measure below 1.2 kilopascal, but we will see later that the pressure is low enough as the water will be in all three phases. This can, however, take a few minutes. After some time, we see both formation of ice on the surface of the liquid water and that vapor bubbles appear in the liquid. We now have a situation where the water is boiling under a thick layer of ice. This is water at its triple point. All three phases coexist. The different phases are, however, not in equilibrium, as the amount of water in each of the phases changes with time. When we switch off the pump, the water will be stable at the triple point as long as the chamber manages to hold the necessary pressure and temperature conditions. Once we open the inlet valve and increase the pressure back to normal, we can see that the vapor bubbles disappear first. Small droplets on the glass bell eventually evaporate and the ice in the petri dish begins to melt. In a second run of the experiment, we also place a small beaker with sulfuric acid in the chamber. The acid attracts water molecules from the gas phase and helps to improve the vacuum. The steam produced during boiling eventually lifts the ice cap in a sudden motion. The triple point of water is used to define the Kelvin scale. Kelvin is the unit for absolute temperature and thermodynamics and one of the 7 base units in the International System of Units. At absolute pressure,
Okay, so anong ginawa lang niya, no, is that you have a liquid water, no, wherein you decrease the pressure, then it starts to boil, no, then suddenly you are here on the triple phase, no. So for example, nandito siya nagumpisa, so dinecrease na yung pressure, so nagkaroon siya ng transition between liquid and the vapor phase. So as a result, nagbabubble yung liquid natin, no? So habang dumadaan siya diyan, nagbabubble yan. Then until to a point na nandito na siya sa triple point, no? Wherein all the phases coexist as one, no? Okay. So, yun din yung reason why pag pumunta ng Baguio, for example, in higher altitudes, yung mga nakatira sa, let's say, sa Baguio, sa Tagaytay, or sa taas ng mga bundok, no? Ma-observe ninyo is that mabilis kumulo ang water, no? Bakit, no? Kasi if you decrease the pressure, no, because of the height, 'di ba? As higher you go, no, sa surface level ng earth, bumababa yung atmospheric pressure, no. So as a result, no, since bumababa yung pressure at higher altitudes, no, bumababa yung boiling point ng water, kaya mabilis kumulo yung mga tubig doon, no. So yun lang, share ko lang. So that's the triple point, no? So now let's proceed with the critical point, no? So again, the critical point is the point at which the liquids and the gases are last seen as separate entities, no? Makikita mo sila magkahiwalay at that point, no? Last point na yon na magkahiwalay ang liquids and gas. Anything beyond that, you will have a supercritical fluid, no? Which happens to be liquid and gas at the same time, no? So let's watch that, no? So, siya pa rin yung guy na magdi-discuss, no?
Every substance has a critical temperature and a critical pressure. When a substance is subjected to temperature and pressure that both exceed these critical values, it enters what is called a supercritical state. Any pure substance can exist in three phases, can be a solid, a liquid, or gas. We can show these phases using a temperature-pressure diagram called the PT diagram. This graph shows the location of the different phases of a pure substance in relation to pressure and temperature, with pressure P on the vertical axis and the temperature T on the horizontal axis. The three phases are separated from each other by so-called separation lines. We have the sublimation line, which divides the solid and the vapor phase. The sublimation line ends at the triple point, which is the point where all three phases coexist. There is a melting line between the solid and the liquid phase, and the vaporization line between the liquid and the gaseous phase. The vaporization line ends in the critical point. The temperature on this point is called the critical temperature and usually gets designated the symbol TCR. The critical pressure has the symbol PCR. These values, together with the critical density, are characteristic for each substance. With pressure and temperature that exceed the critical values, the substance will become supercritical and the differences between the liquid and the gas phase disappear. Let's see how this works in practice. For this experiment, we made our own pressure tank. It has a thermometer, a pressure meter, and a pressure relief valve. We also have some dry ice, which is carbon dioxide in the solid phase, a heating plate, and a heating base. We put some dry ice into the tank and seal the tank. As the pressure tank is completely sealed, the pressure builds. The dry ice starts at a low temperature, but with the rising pressure, it soon turns into a saturated liquid vapor mixture at about 40 bar and 5 degrees Celsius. By applying heat to the tank, we increase the pressure and temperature towards the critical point at constant volume. CO2 has a critical temperature of 31.25 degrees Celsius and a critical absolute pressure of 73.9 bar. So we want to heat up the carbon dioxide to its critical temperature, and because the volume of the tank is constant, we can also build up the pressure. As the pressure and temperature reach the critical point, the distinction between the liquid and gaseous carbon dioxide becomes less visible and eventually disappears. The phase boundary between the liquid and the gas vanishes. The CO2 is now in a supercritical state. To return to a state below the critical point, we will cool the carbon dioxide and make it reappear in the saturated liquid vapor mixture. By removing the heating plate and then adding dry ice on the aluminum cylinder, we can observe that the liquid suddenly reappears as the temperature decreases. We have returned to the saturated liquid vapor mixture. Supercritical CO2 is used in a variety of applications, for example, to remove caffeine from coffee beans.
Okay, so what just happened, no? So, dito sa part ng video na to, ito. So, tignan natin to. We can part that is the gaseous part. Ay, nawala na. So, this is the liquid part. This is the gaseous part na. So, andun sa taas na. However, as soon as you reach the critical point and the fluid becomes supercritical, what will happen is that mawawala yung boundary na yan. Just as shown here. Yan. So, di ba, wala na yung boundary. So, that means you have already a critical fluid in that point. No? Okay. So, with that, yan lang naman yung gusto ko patunayan dito after natin manood ng mga ganyan. So, we're done with the last topic for this chapter. No? So, the intermolecular forces, liquids and solids, and the phase diagrams. No? So, ano na lang yung task nyo? So, you do not have any, ano ngayon, no? Wala tayong worksheet ngayon. So, ang task nyo na lang is to complete the quizzes, no? And yun, reread all the, basahin nyo na lang uli yung mga materials na in-upload ko rin dito for Chapter 5 discussion. So, yan. Nasaan ba yun? MT27. So, yan. So, download nyo na lang itong mga to, no? So, yan. Puro reading lang naman yan. Okay, so with that, that ends the inorganic part of this subject. So that means midterm exam nyo na sa October 12 to 17. So I wish you all the best, no? So if you want to review, kunwari, gusto nyo mag-review simula day 1 until now, just go to announcements, hanapin nyo yung recorded class discussions. So, sanapin nyo dito yung mga chapters. No? Chapter 1 to 5, andito yon. Kunwari, gusto nyo, day 1. Ito, MT27. Chapter 1, day 1. So, nood kayo niyan, no? Kunwari, chapter 1, day 2. So, yan. Manood na lang kayo ng mga videos dyan, no? So, you can review. No? Kung gusto nyo makisit in sa iba kong classes, kunwari, gusto nyo makinood ng paano kaya ako mag-lecture sa lab, no? Paano yung lab classes ko. You watch any of the lab videos there, no? So, yan. Pwede sa biology, pwede sa MT, no? So, yan. So, nood na lang kayo ng mga videos dito. Binge watch, ika nga, no? So, mag-watch na lang kayo ng mga videos prior to your examination. So, next week, we will have no pending activities na naman as we covered all the topics. What I want you to do is to prepare for your examination. So, sagot kayo na quizzes. Tatlong quiz yung due on October 11. Quiz 4, part 1 and part 2. And quiz 5. No? So, for quiz 4, part 2, you have 2 chances. For quiz 5, you have 2 chances as well. No? Para mas lalong ma-check. Para mas lalo kayong maka-realize na, ay, ganun pala. No? So, yan. So yan, and also you can rewatch other classes nga, no? Kunwari gusto niyo manood ng lab ko, mamili lang kayo diyan kung anong lab class gusto niyo salihan, no? Okay, so yun lang naman. Yan, so good luck po, no? Yun. Any questions po? Or okay na tayo? Kasi ako, okay na ako. Tapos na yung lessons natin, no? So, it's more on preparation for the quiz and the examination na lang. So, do you have any questions po, concerns, or okay na tayo? No, baka nagme-merienda kayo na. Okay, so anyway, so okay na po, no? So sige, so enjoy the weekend kung walang klase bukas and all the best po. Sige, Nikolai. Paano po yung sa quiz? Isang quiz ba? Paano po yung sa exams? Day 1 lang po ba? Ganito yung exam, no? For the midterm exam. Itong October 12 to 14, dito open yung inorganic. Dito lang, within this time frame lang open ang inorganic chemistry. Ang kasama ko dito is si PMLS1, no? Dito naman si Ana Finyo, 15 to 17. Wala kayong classes this time kasi puro exam lang to, no? So wala kayong classes the whole week, puro examination lang. So the inorganic will be done here, 12 to 14. Dito yung ANAFI, no? Dito yung PMLS1. Ilang items, no? Usually the examination is 50 items lang. Each is worth 2 points para maging 100 points ang quiz, yung exam, no? I don't know, pero usually 2 hours ang time frame para sa para sa examination. Yun sa mga items naman na mali sa Canvas, napansin ko doon mostly formatting issues, no? Kasi may mga students na instead of O ang ilalagay, ang nilagay nila ay 0. So, imamali ng Canvas yan. Pero ako, I will check all of them, no? Starting next week, no? Kasi tapos na ako sa classes ko, no? So, I can focus on reviewing all the responses you made, no? So, yan. So, i-check ko yun manually, no? After the deadline, which is October 11. Yung mga maling formatting, i-consider ko na lang. Yung mga hindi nag-follow ng format, ako na bahala mag-consider sa mga items na yan. No? And ito pala, for the examination, no? Kunwari, walang mag-load na picture, take a photo and wag nyo sagutan yung item na walang picture, no? So I can cross-check all the items na wala nga picture or meron, no? So ganun lang. And again, no, yun, galingan nyo na lang po, no? Again, yung sa quiz, no, yung mga corrections sa quizzes, i-check ko siya after the deadline, no? So titignan ko yung mga responses nyo. Kung mali yung formatting, consider ko na lang, na. So yan. Pero sa susunod, follow the formatting, na. So kung O yun, wag ilagay yung 0, na. O dapat. So yun lang. Okay, so yun lang po. Any other questions or concerns? Okay, so wala na, no? So basta galingan nyo na lang, ha? Again, if you want to watch other classes, no? Kung wala gusto nyo manood ng lab, class ko, or ng iba kong lectures, again, no? So punta lang kayo sa YouTube channel natin, no? So scroll lang kayo doon ang pwede panoorin. So yan. So you have all the materials naman. You have all the videos posted on YouTube. So madali mag-scroll. Punta lang kayo ng Canvas. Kunin nyo yung link ng channel ng playlist, no? Naka-private kasi. Tayo-tayo lang yung may access ng playlist na yan. Okay, so with that, okay na tayo, no? So, sige. So, thank you very much and I'll see you on next time, no? So, sa Friday, next meeting, pwede kayo mag-consult sa akin, no? Pero pwede rin kayo mag-review na lang, no? So, yan. All the best, no? And malapit na matapos yung semester. So, good luck. po, and God bless as always. Na. So, the recording of this class discussion will be posted on YouTube mamaya-maya na.